Hey guys, this is the video lesson for patterns and data. Make sure you have it split screen with the Google Slides that are posted in Google Classroom as well. All right guys, our first definition is what we call a bell curve. This is when the entire graph is shaped like a bell. So the shape of the graph looks like a bell. And for example, on your number line below, if you can, that would be like putting a dot at 35 and a dot at 30, and then 2 dots at 31, 2 dots at 34, and then 3 dots at 32 and 33. So what you see is, let me do a different color, the graph goes up and then comes back down. So it's shaped like a bell. Goes up in data, down on the other side. Okay? All right, our next ones are left and right skew. So most of the answers are at one end of the graph, with very few at the other. So the side with the tail, or the few answers, names the graph. So what we mean by that is right skew has few answers on the right side, and left skew has few answers on the left side. So I'm going to give you both examples. I'll put the right example here and the left example here. So a right skew would have very few data on the right. So I'm gonna put like 1 point at 35 and maybe 1 point at 33. And then most of my data is going to be over here on the left. So I'm just gonna put a bunch of data points at 31, 32, and also some at 30. Oop. So notice that most of our data is on the left-hand side with very few over here on the right. So that would be a right skew, and then the opposite would be on the left skew. So left skew is when little data is on the left, or the tail is what is giving us our name. So I'm gonna put just a few at 30 and 31. And then most of my data points are going to be at 33, 34, and 35. Something like that. So notice how the majority of our data is over here on the right, with very few on the left. All right, this next one is uniform distribution. Graphs that don't have any shape at all. So the data is very even without any clusters, gaps, or curves. Most answers received around the same number of responses. So that means, for example, if I were to put 2 at 30, 2 at 31, 2 at 32, 3 at 33, 2 at 34, and 3 at 35. Notice how they are all very, very similar and have no clusters, gaps, or curves in the graph at all. Okay, this next one is called a gap. This is intervals that contain no data. So it's exactly how it sounds. It's a gap in your data. So an example would be is if I put 1 at 30, 2 at 31, nothing at 32, 2 at 33, 1 at 34, and 1 at 35, my gap would be at the interval 32 because there's no data there. All right, this next one is a cluster. It is a group of answers or data that stand separate from the rest of your data. So it's often surrounded by gaps. An example would look like if I put nothing at 30, maybe 1 at 31, nothing at 32, and then most of my points at 33, 34, and 35. So in this case, you have a gap at 32, and then your cluster would be from 33 to 35. All right, this is a peak. You want to think about mountain peaks, high points in the data set. So that would be like saying if I put 1 at 30, 4 at 31, 2 at 32, 1 at 33, and then nothing at 34 and 35, my peak would be at the number 31, because that's the highest point of my data set. And looking at to the right and to the left of my peak, it's a big drop off on both sides. All right, symmetry. We've all heard this word before. It is when one side of the graph is the approximate mirror image of the other. So we can draw a vertical line, which would be called our line of symmetry. And then that way the left and right sides will both be approximately a match. So for an example, that would be if I put 1 at 30, 2 at 31, 3 at 32, 3 at 33, 2 at 34, and then 1 at 35. I could draw a line of symmetry right between 32 and 33. I'm going to put line of symmetry because now both sides of my data are the same, right? Both sides of that line of symmetry are identical. Okay, so let's take some data results and practice describing the distribution and figuring out if there's gaps and clusters and lines of symmetry. So taking a look at this, we have a histogram, right? We learned all about those last week. So number 1 said, describe the distribution. So when we ask you that, we're looking for you to either say it's a bell curve, it's right or left skewed, or if it's uniform distribution. So looking at this graph, we can notice that it's going to be a bell curve because remember it starts low, goes up, and then comes back down on the other side. So our distribution for this graph would be a bell curve. Looking at our data, are there any gaps? So each of these intervals has data at it, so there is no gap here. Remember, a gap is when there's no data at all. And then following that, are there any clusters? So remember, clusters are normally surrounded by gaps. So if there's no gap, there's no cluster. We don't have one cluster of where most of our points are. So nope. Are there any peaks? So remember, you're thinking a mountain peak. And looking at this graph, from 50 to 60, that interval has a peak in the data. So for that question, we weren't just looking for a yes or no. Make sure it says name any peaks. So you want to name the interval. So that's why I put from 50 to 60 because that was the name of that interval. All right, number 4 says, does the graph show symmetry? Explain why or why not. Draw a line of symmetry if there is one. So in this graph, it might not be perfectly identical, but there still is a line of symmetry, so we can put yes. And I say that because where your peak was, so at 50 to 60, if I draw a line straight down it, as straight as you can get it, I'm going to make that my line of symmetry. Now, although they're not perfect on both sides, they're very similar on the left and the right. It's almost a perfect mirror. So my answer was yes. Why? Because they're mirrored on both sides, right? The left side of my line of symmetry and the right side have very similar data. And then draw your line. All right, this next one, number 1, describe the distribution. So we're not looking at a bell curve. It doesn't go up on one side and down on the other. Uniform distribution is when they all are very similar or the same across the top. So it has to be either right or left skewed. Now, a lot of people always want to say, oh, most of my data is on the right, so this has got to be right skewed. But remember, the side that has the small amount of data names your skew. So because there's small amount of data on my left side, this is going to be a left skew. Okay, that's where your tail is, or where the least amount of data is. Number 2, are there any gaps? So first we put yes, because there absolutely is gaps here, and then we need to label them. So remember, you look for the interval. In this case, we have a gap at 26 and 32. Are there any clusters? Again, the answer is yes. We're looking for a cluster of data, and that would be from the intervals 34 to 40. So it's 2 parts. You're going to say yes or no. If it's a no, nothing else to answer. If it's a yes, you want to name that cluster or the gap. Now, this last one we haven't talked about yet. So it says, name any outliers in the graph. An outlier, I like to say, is an outsider. So that is any point that is far away from all of your other data points, right? It lies outside of where the majority of your data points are. So in this graph, or in this dot plot, my outlier would be all the way over at 24, right? It lies outside the rest of the data. It's an outsider. It is all by its lonesome. And then number 4, does the graph show symmetry? Explain why or why not. Draw a line of symmetry if there is one. This graph does not show symmetry. And if you think about it, if it is skewed to the left or to the right, that means most of my data is on one side or the other. So that means it can't be symmetrical, because if I drew a line, most of my data would be on one of the sides, not looking similar on both sides. So that last one's just going to be a no. All right, this is a dot plot for books read last summer. We have to describe the distribution. So looking at this, it's not a bell curve, right? It doesn't go up on one side and down on the other. It is not uniform distribution, because all of them are not very similar across the top. So it has to be right or left skewed. We learned that whichever side of your graph has the smallest amount of data, or where the least amount is, will name your distribution. So small amount of data is on the right side, so this is a right skewed distribution. Are there any gaps? Yep, there is no data at 6. So we'll put yes, and then the number 6. Are there any clusters? That would be a yes, because there is a cluster of data from 0 to 5. Are there any peaks in the graph? The answer is yes. You can clearly see at the number 1, there is a high peak. Remember the mountain peak. So when it asks you to name it, your name would just be the interval at number 1, right? Interval 1. Then lastly, does the graph show symmetry? Remember, very similar to our explanation from the last question. If it is right or left skewed, it is not going to be symmetrical. There will be no line of symmetry for this. All right, there are 3 more slides that you are going to practice on your own. There's an answer key linked in the unit plan. Please make sure you check your answers before you are completely finished. Don't forget, help sessions There's one at 11 to 12 and 1 to 2. See you later.